From the previous discussion related to the inverse of the original function, we have known for this original function, its inverse should be represented by this equation, that is say y equals x minus 1 over 2. Now let's summarize how to figure out the inverse of the original function. Okay, here we use y to replace the fx. Then we can figure out this equation. Now, if we want to figure out the inverse of the function, that is say, if we want to figure out this expression, we need to consider the equation like this. First, we need to use x to replace this y, and we use y to replace the x. The left items, we just need to copy them. Okay, then we get this new expression. Of course, here I use the x in uppercase, the y in uppercase. My aim is to differentiate this expression from this expression, but in fact, you just need to use x in lowercase, y in lowercase to replace this one. Then, for this equation, you just need to figure out x minus 1 equals 2y, y equals x minus 1 over 2. Right? This equation is just this one. Here, why we need to use x to replace this y? We use y to replace this x because for this point P on the original function, you know, this x coordinate, this number should be the y coordinate on this line. For the corresponding point P, that is say, the symmetrical point over this straight line y equals x. That is say, the y coordinate, x coordinate should be reversed for this point P prime. So here, we use x to replace y. We use y to replace x. That is say, in the future, on the graph of the inverse, this point, its x coordinate should be got from these coordinates, but we just need to reverse x coordinate to y coordinate and y coordinate to the x. So for this point, it should be x comma y. Okay? Then we get this expression. This expression represents this straight line. Okay? And this point, the x coordinate, y coordinate is x coordinate 0, y coordinate negative 1 over 2. Now let's focus on this point and this point. You will find out this point is on the y-axis. This point is on the x-axis, right? This x-coordinate is just the y-coordinate. This y-coordinate is just the x-coordinate. For this point B and the B prime, this x-coordinate is the y-coordinate. This y-coordinate is the x-coordinate. We can say we reverse the two coordinates, we can get the corresponding point on the inverse of the original function. Now, if we connect these 2 points, we can figure out the line segment AA prime, the line segment BB prime. Here, the midpoint, here, the midpoint M. You can easily figure out the midpoint coordinate should be 1 over 2, 1 over 2. This point, its coordinate should be negative 1 over 4, negative 1 over 4, right? You will find out the x coordinate equal to the y coordinate. the x-coordinate equal to the y-coordinate. So this point M and this point N should be on the straight line. This straight line should be y equals x. So if we connect these 2 points, we can figure out the straight line y equals x. Of course, the origin must be on the straight line y equals x, and the POI between this straight line and this straight line, this point must be on this straight line. Okay, so this is the further discussion related to the inverse of the original function. Now, you need to know the inverse of a function. For this example, its inverse is represented by the blue straight line. We can easily judge this relation is also a function, because from the algebraic expression, you can figure out for every different x, you can just only figure out one y value to correspond the x coordinate. In geometry, this blue straight line can pass vertical line. That is to say, for any vertical line, this relation just has only one intersection with the vertical line. So we can say the blue straight line can pass vertical line test. So we can say this relation is a function. So in geometry, in algebra, we can conclude that the inverse of this original function is also a function.